Okay, here's a question about sequences. We have a rule for generating successive terms, but the rule's expressed in terms of p and q, which we don't know yet. However, what we do know are the first three terms of the sequence. And in part A, we've got to find p and q, and they give us the value of p, but we can forget about that for now. We've got to end up with that and end up with a value of q. So what we need to do is find some way of applying all the information we're given, and the way to do that is to say that this tells us how to get the next term when you know the term before it. So we can do that twice. We can do it first time with u1 and u2. When you put u1 200 into this expression, the answer for that must be u2. So if you substitute those values in, leaving p and q as letters, you'll get one equation linking p and q. And then if you do the same thing with u2 and u3, you'll get another equation with p and q. And then you solve the simultaneous equations so that you end up, convincingly, with p as that value and a value of q. In part B, we've got to find the value of u4. Well, now we know p and q, all we need to do is plug u3 into this equation and the known values of p and q, and that will pop u4 from arc. And then in part C, we're told that the limit of un as n tends to infinity is L. So if we keep going, generating more terms, they'll get closer and closer to this value of L. But in order to get any marks for this question, you don't need to generate any more terms. In fact, it's wrong to try and get L that way, because we want the exact value of L. And there you have to use the idea that we generate an equation for L. Where's that equation going to come from? It's going to come from here. Remember, we know p and q now. While you're working through terms of the sequence, un and un plus 1 will always be different. But the further you go, if it does reach a limit, the closer together these get. And in the limit, both un and un plus 1 will reach, if you could get there, this value L. So you assume you do get there, and you replace both the un and the un plus 1 in the equation by L, and there's the equation you need for L. So the u's disappear, turn into L's, and then you solve that equation to find the value of the limit L, which will be a nice exact number. And there's a worked example of exactly that method in your Core 2 booklet on round about page 7.